All right, hello guys. Your next video is on evaluating limits algebraically. So we've just spent a big chunk of time either looking at graphs that we were already given and finding limits, or making our own graphs and then finding limits. Now we're actually going to work on evaluating limits algebraically instead. All right, so from our investigation in class, hopefully everybody understands this point. But if you evaluate f of a, and f of a is a real number, which means that there's no undefined values. There's no piecewise function where a is the breaking point. Right? That's what it means for f of a to be a real number. It means we were able to plug it in and we were all good. Okay? So that means then that the limit as x approaches a of f of x has to be f of a, which really just means we're going to just plug it in. All right, so as long as there's no problems, we get to plug it in and we're all good. So to find the limit of x squared minus 4x plus 3 as x approaches 5, we're going to take 5 and just plug it in for x. So we'd have 5 squared minus 4 times 5 plus 3. 25 minus 20 plus 3, and we end up getting 8 as our final answer. All right? We know that this is just a parabola. There's no problems with a parabola. Okay? Question 2. If we look at this, x to the 7th minus 2x to the 5th plus 1 raised to the 35th power. Well, yeah, okay, I could graph that, but I definitely don't want to, right? The parabola, I can graph that without really thinking much, but this, I don't know what that's going to look like. But I do know that it's going to be a polynomial. So I can just take 1 and plug it in. So I'm going to have 1 to the 7th minus 2 times 1 to the 5th plus 1, and that's all raised to the 35th power, which really just means that on the inside I've got 1 minus 2 plus 1 raised to the 35th. And hopefully you guys agree with me. That just becomes 0 to the 35th power, which is really just 0. Okay. Question 3, we've got this rational function here. The problem would be at x equals 3, but we're plugging in x equals 2, so we can just evaluate that one too. So 5 times 2 to the 3rd plus 4 over 2 minus 3. 2 to the 3rd is 8, so we'd have 5 times 8, which is 40, plus 4 over negative 1. So we get a final answer of negative 44. All right, so the first thing I would do is check to make sure that the value that we're trying to evaluate the limit at actually works in there, because if it does, you can literally just substitute it. All right, that's the best part about some of these ones. Now, if you have a piecewise function, things get a little trickier. So if we have a piecewise function, one-sided limits, we're just going to substitute the x value into the appropriate side of the breaking point. Okay, so if all they're asking for is the limit as x approaches the left or the right of that breaking point, we only have to plug it into one of the functions. If we're looking for a two-sided limit, we have to check both sides. And notice, this is only important when the x value is the breaking point. Okay? It's only important when the x value is the breaking point, which means if I'm evaluating something that's not the breaking point of my piecewise, I can just plug it into whatever part I want. Okay? So let's take a look at this one. We've got this piecewise function here, and our breaking point, I'm going to circle it over here. Our breaking point clearly is negative 2. Because our function is this parabola for when x is less than negative 2, and it's this line for when x is greater than or equal to negative 2. Now, we could graph this like we did in the last section and find the limits from there, but evaluating it algebraically is much easier. So let's take a look at the first one. So the limit as x approaches negative 2 from the left. Well, that means that we want to look at when x is less than negative 2, which means we want to focus on the parabola portion. So we're going to take the negative 2 and plug it into the parabola. So negative 2 squared minus 8 times negative 2 minus 15. Negative 2 squared we know is positive 4, but then we have a negative on the outside. So negative 4 plus 16 minus 15. And so we end up getting, what is this, 12 minus 15. So we get negative 3 as our answer. All right, now if we were to graph this, we would have an open circle at negative 2, negative 3. And that would be okay, but it still tells me that my left-sided limit is negative 3. All right, for my right-sided limit, again, negative 2 is my breaking point. So I do need to look at the right-sided limit. So I want the line here. So I'm going to do negative 2 x minus 6, and I'm plugging in my negative 2. So I get positive 4 minus 6. So my right limit is negative 2. Okay, now I'm looking at the limit as x approaches negative 2 of f of x. Well, negative 2 was my breaking point. And I just found my left-sided limit and my right-sided limit already. So I know that this overall limit doesn't exist. All right, and the reason I know it doesn't exist is because the limit of f of x as x approaches negative 2 from the left doesn't equal the limit as x approaches negative 2 from the right, because the left limit was negative 3 and the right limit was negative 2. So we already did all the hard work on there. Okay, so it does not exist because the left limit doesn't equal the right limit. Then when we look at this next one, we're looking for the limit as x approaches negative 3. That's not my breaking point, which means really I just need to figure out which piece I need to plug it into. So x negative 3, which means, oh, that's less than negative 2, so I'm going to plug it into my parabola. So negative 3 squared minus 8 times negative 3 minus 15. So I get a negative 9 plus 24 minus 15, which means all that cancels out, and I know that my limit is 0. Again, I don't have to check the left and the right because negative 3 is not my breaking point. Okay? Moving on. If you have any questions so far, please make sure you've written them down. And even as I keep going, write down the questions. We'll talk in class, okay? I don't want you guys to be confused. All right, now we're going to look at calculating limits where we can't just substitute. So we said we have problems if we plug it in and we get an undefined value, or if we have a piecewise. So we just looked at a piecewise. Now we're going to look at what happens if I tried to take negative 2 and plug it in there. I would have 0 on the bottom. That's a problem because I can't divide by 0, which means I have to do something else. So we've got 3 different options, all right, that we're going to talk about. We can try factoring, we can try multiplying by a conjugate, or, you guys can't see it on the screen at the bottom yet, down there we go, you can try eliminating denominators. So we're going to focus on the factoring first. All right, when we look at this, hopefully you guys can recognize right away that the top there, x squared minus 4, is the difference of squares. So I can factor it as x minus 2 times x plus 2. And on the bottom I have x plus 2. And I know that those will cancel each other. And this whole thing just simplifies down to x minus 2. Which means when I look at my limit, this is really like saying take the limit as x approaches negative 2 of x minus 2. Now I don't have any problems because I eliminated that x plus 2. So now I can actually just substitute negative 2 minus 2, which means my overall limit is negative 4. By factoring and canceling the common factors, we're able to substitute. We're able to do it the easier way. Okay? The next one we've got here is multiplying by a conjugate. And I feel like when I say that, people like freak out. So please don't freak out, okay? Multiplying by a conjugate. So when we look at this here, we've got x minus 1 over the square root of x minus 1. Now, most likely, you guys multiplied by conjugates when you were trying to simplify denominators. Okay, so we're going to throw these in parentheses real quick, if you didn't already. We're going to multiply by, this time, the conjugate of the bottom. However, I'm just going to point out that sometimes we might have to multiply by the conjugate of the top. All right, we'll work on some of those in class. But for now, we're going to multiply by the conjugate of the bottom, which means we're going to multiply by the square root of x plus 1 on the top, and the square root of x plus 1 on the bottom. The reason we have to do it on the top and bottom is because really, this right here is just a fancy 1. All right, we're not changing the problem at all by multiplying by the number 1. We're just picking a fancy one so that we can make it a little bit easier to deal with. Because right now, by the way, I forgot to mention, if you plug 1 in right now, we get a 0 on the bottom also. Okay? Now, hopefully, you guys are okay with multiplying these conjugates on the bottom, but really we're just double distributing. So the square root of x times the square root of x is x. The square root of x times 1 is square root of x. And then we're going to distribute the negative 1 and have minus the square root of x and then minus 1. Now, on the top, I'm not going to actually multiply those out. I'm going to leave them separate. So I'm going to leave it as x minus 1 times the square root of x plus 1. All right, so we only multiply where the actual conjugates are. Okay, so now on the top, I have x minus 1, the square root of x plus 1, and hopefully you guys can see on the bottom that those square roots cancel each other. I've got positive square root of x and a negative square root of x. So I'm left with x minus 1. And then that also cancels, which means we just simplified this whole thing to just be the square root of x plus 1. Okay? So now I'm going to come back up here to my limit, and I'm still doing the limit as x approaches 1, but now it's not this x minus 1 over the square root of x minus 1. It's just the square root of x plus 1. Okay? So the square root of x plus 1. Now when I substitute 1 in there, there's no problems. Square root of 1 plus 1, and we know that that equals 2. All right, so we only do all of this stuff when we can't substitute. So option 1 was factoring. Option 2, multiply by a conjugate. Now we're going to try and eliminate the denominators. This is another thing that I think when students see it, they like freak out. So please don't freak out, okay? We're going to just eliminate the denominators. We're going to make it easier to deal with. So the very first thing that I would do, ignore the limit part. Well, actually, let's look. Limit as x approaches 1, we would get 0 on the bottom. All right? Don't feel like I need to check it, but just in case. So ignore the limit. And we've got 1 over x minus 1 minus 1. But if it's okay with you guys, I'm going to make it 1 over 1. And then all over 1 over x minus 1. So all I did was rewrite this function that I have here down here without the limit part. Okay? I want to eliminate the denominators. So what I'm going to do is I'm going to multiply the top of every fraction here by the least common denominator. All right, you might be having some flashbacks to Algebra 2 if you guys did this back then. But the LCD here, well, my denominator here is x minus 1. My denominator here is 1. My denominator here is x minus 1, which means my LCD has to be x minus 1. So I'm going to multiply that on the top of every fraction that I have there. Okay, and when I do that, it kind of does some nice stuff for me. So over here, these x minus 1s cancel